horizontal turbine. And again, the big question is, where do you have enough water movement to make this work? But what you can imagine is, this would be all down the coast. There would be a jillion of these things as you follow the tide line down the coastline.
Would they be close enough to shore to like have to shut down all the beaches? Like, you know, like swimming?
I don't know about the placement. I think you want to put them where they're always submerged. So you want to put them technically below the low tide line. These are kind of cheating. I put those in the wrong place. As the water comes up and down the sandbar, so as the tide is moving up and down, it would force water along the bottom. And anybody who's been scuba diving has seen that surge along the bottom. It picks up sand. It's pretty powerful. So these use what's called surge energy.
And they're like safe to swim.
Now, the one really good thing about them is that there's almost always surge down there. If you find places that have pretty dynamic tidal action, surge is damn near 24/7, almost all day. The flip side is the engineering for this and the placement is kind of limited.
How much water should you produce?
I don't know because I'm not aware of any of these actually turned on right now. They have tried these as an alternative to these, and for an equal volume of water flow, you get more electricity because it runs 24/7 as opposed to just at those moments of maximum advantage.
And then ecologically stable environment.
I don't know, man. The sea bottom is actually kind of important too. A lot of question marks with that.
This is really situational. I like the engineering.
Yeah, situational these all are. Okay, next. Comes the fanciest name of all. You've got to know this one because I think this is the really cool one. Oscillating water column. AKA water piston. Now, I gotta talk about bathtub time. If you take like a Tupperware and you turn it upside down and you push it into the water, it traps air. That air wants to float, so if you let go, the Tupperware will go boop, come to the surface. Even better, imagine if you trap air and then put a little tiny hole in the Tupperware, the bubbles will go spraying out as the water rises inside of that. Even better, what if you take your Tupperware, watch me turn it upside down underwater, trap that water, and then as you bring it out of the water wants to sink in. So if you had a little air, the water would suck through that little hole, right? Instead of moving the Tupperware, what if we could just move the ocean? Oh wait, it does. So, on the coastline, you build a shape like that. As the ocean moves up and down, it will drive a piston of water up and down on the inside. Everybody following me? And then if we have a little vent, then we can use this air a turbine. You use the water to create the air pressure, and then you do a bunch of funky engineering and fancy plumbing to let the air go in and out of the turbine. And so this is your energy source. Now this is very low impact. Aside from your coastal interface, you got to give up some like beach spots. But imagine even better. What if on the coastline you had a pier? Or maybe a bunch of piers. And along the pier, you had a bunch of these boxes. And all of those had a pipeline of pressurized air spinning a really big old turbine. Feel me? As the ocean goes down, in like 50 of those pistons, and they're all sucking a ton of air in, and as the ocean comes up in all of those pistons at once, they're forcing air out at tremendous power. People have talked about these funky clutches and then having separate plumbing for the in air versus the out air, so there actually be a separate set of turbines for the blowing air and the sucking air. There's all kinds of funky engineering that you've got to do. And this, personally, I think is the most promising. You could put these floating in the ocean. You don't even need coastline. Right? If you anchor the rig to the bottom, the surface of the ocean is moving up and down anywhere you are. You know, those oil rigs, they still have high tide, low tide. And by the way, they also work on wind energy because you can just get like the swell power. These use swells as much as high tide, low tide. Yeah.
Do you do it like the garage where you wait until the difference is maximum and then run it through?
No, the good news is most places, if you're in active parts of the ocean, the water's pretty much always moving. Like if you have swell coming through, that piston's always doing one of two things. So it's either pushing air into the outflow turbine or sucking air from the intake turbine 24/7.
Okay. So you're not like sealing it off and like letting it drop down the whole water and then letting it go.
No. I guess you could. And by the way, there may be an engineering benefit to that I haven't thought of. I don't know. I'm just kind of off. I'm just shooting. Yeah, that sounds good, man. Like off the cuff here, but the idea is the oscillating water column, that piston that creates the pressure. Then the engineers will make all those decisions for us. Yeah.
Does this exist anywhere?
I don't know. I don't know yet. I'm sorry. Okay. And finally, there's one more option in the ocean. This is my last one for ocean power, and then we'll move on. Am I out of time, by the way? How much do I have? How much time do I have? How much? Thank you. This is being already experimented with in Hawaii. They've already got one of these. It's called ocean thermal. And the secret of this is that in some places, the top of the ocean gets pretty stinking warm. Of course, down below that, anywhere you are, if you go deep enough, it's really cold. So, you can imagine,
if we have the right liquid and the liquid is the question mark, on the surface, sorry, I have to draw at the moment. I'm not a very good drawer. I'm kind of distracted. We inject our liquid. It gets cold down here. And there are substances which boil at a very low temperature, like perhaps ammonia. Boiled at such a low temperature that when it comes through the hot surface water, if you increase the contact time, you can make it evaporate. And then you can use that steam, spin a turbine, make your electricity. And then you just have to recapture the ammonia mix. It'll go to liquid when it goes down, and it'll go to vapor when it passes through the hot water. Yeah?
How toxic is ammonia?
Ammonia is not that bad. It's extremely toxic if you drink it straight up, but if you put it in the atmosphere, it essentially disappears. It's with that.
So like if there was like a spill, like an oil spill of ammonia, what would happen?
Localized, a lot of damage. But as soon as it dissipates into the water, probably negligible. There's already a lot of ammonia. Poo is ammonia. So it's about as toxic as the ammonia part of poo. For fish, it can kill them. In an aquarium, if you're not filtering the water, they'll eventually die. But ammonia breaks down very easily. Denitrifying and nitrifying bacteria eat that. Yeah?
That's a picture of an oscillating waterfall.
Oh, cool. So I guess it works?
Yeah, I guess so.
You want to put that onto the internet?
Sure.
Yeah, it does. That's cool. It'd be neat if I could actually, more than the picture, have more info about that installation. Now, these seem to be the least likely today. This is sort of, the mix is the secret. This is the critical detail. But if you can get the right stuff, the idea of using the hot water to generate the steam, that is actually pretty, that's reasonable. That's not out of the question. Keeping it all under containment, that's not that big of a deal. All right, children, bye-bye.